Hey, good morning again, everyone, and welcome to our subject. And for today, after dealing with determinate structures or yung mga structures natin na can be solved using yung equilibrium equations natin, we will now go to structures that has redundant support. So, ibig sabihin, more than uh, more than three yung required na solution para sa kanya. Di ba dati, sinasatisfy natin yung condition na dapat gagamitin lang natin is a summation fx, fy, tsaka si moment. Pero ngayon, yung three formulas na yun, yung equations of equilibrium natin na yun, are not enough to solve for our beam. Na sabi natin nung uh, we are discussing the stability of our structure, when our structure is or has a redundant support or na greater than 3 yung value ng kanyang number of unknown reactions, sinasabi natin siyang statically indeterminate, and then ina-identify na lang natin kung anong degree ng indeterminacy niya. So ngayon, after dealing with deflection, using yung double integration method lang yung na-discuss natin dahil na din sa time constraint natin, no? Supposedly dapat ma-discuss pa natin yung ibang methods like area moment method and yung other methods in solving for deflection. Pero I opt to advance na lang the topic to indeterminate structures so that you will have a background dito sa indeterminate structures. And para ma-utilize yung napag-aralan natin ng semifinals is yung discussion natin for today is not one of the general methods used to solve for the reaction ng indeterminate structure or indeterminate beam. Um, Ginawa ko lang, i-utilize again natin si double integration method to solve for the reaction natin. Na later, I will discuss na by next week na lang yung isa sa method na kailangan nating malaman on how to calculate for the support reaction of the indeterminate beams. Okay? So for this lecture, ito yung ating outline. So first is an introduction or just discussion of general methods of analysis ng indeterminate structures. And then yung integration method of solution, again, yung double integration method, how can we utilize it and use it on this kind of problem. And then we have two example problem to reinforce our learning in using double integration method in solving for the reaction of indeterminate beam. So, learning outcomes natin for today is to discuss to you the methods needed to solve the reactions of indeterminate beams and also to demonstrate how the double integration method is used to solve for the reactions of our given examples, right? So, let's start. So, again, we have already identified this before, pero a structure is statically indeterminate when the static equilibrium equations, so itong sinasabi natin static equilibrium equations, if you cannot recall, syempre, yun nga yung binabanggit ko kanina na summation of fx, summation of fy, and summation of moment natin are not enough, no? Or insufficient for determining the internal forces and reaction ng structure natin. So as you can see here, we have a continuous beam, no? Kung wala yung nasa gitna, let's say ito, assume natin na wala yan. This is just a simply supported beam, and I am sure, siguro confident enough na marunong kayo mag-solve ng support reaction, no? Ng kapag simply supported lang siya. But how can you solve if it's in a continuous condition na or meron na siyang redundant na na support? Ibig sabihin ng redundant, kahit tanggalin natin tong gitna, magiging stable pa din yung structure natin. Ibig sabihin, na naging redundant siya kasi stable na nga yung structure natin, naglagay pa tayo ng additional support, siguro nilagyan natin para for more stability or for more para mas matulungan natin yung biga natin. Kung halimbawa, in-expect natin na in the future, yung loading ng beam natin will be increased or meron siyang mga different unexpected loadings na pwedeng subject sa kanya. So kaya tayo naglalagay ng redundant na support or nagdadagdag tayo ng additional, halimbawa, column, no, dun sa beam natin. So yung summation of fx, fy, and moment natin will not be sufficient to calculate yung lahat ng reaction natin kasi we will have um, four unknowns pero ito yung unknowns natin. We have yung horizontal, vertical, ayan. And then, yan, meron tayong apat na unknowns, no? And then, ang formula natin tatlo lang. Ang kailangan natin, kung ilan yung number ng unknowns, dapat yun din yung number ng formulas. Nandito, sa statical indeterminate beams, i-utilize natin ngayon yung tinatawag nating compatibility equations or conditions, no? Compatibility conditions. Okay? So, yung compatibility conditions, actually ginagawa na natin yung isang klase niya dun sa previous topic natin, which is yung pag-identify ng boundary conditions natin. Okay? So, by using yung boundary conditions natin, we were able to get yung value ng mga arbitrary constant natin, no? Yung mga constant of integration natin na C1, C2. Okay? Pero ang additional na pwede natin gamitin for compatibility is to relate yung mga segment natin with each other na later ipapakita natin through example. Okay? So, in analyzing any indeterminate structure, it is necessary to satisfy the equilibrium, compatibility, and yung tinatawag na force displacement requirement for the structure. Okay? So, force displacement requirement depends upon the way the material responds. So, ito, we will discuss this on next week na lang, yung more detailed about force displacement requirement natin. Pero for now, I'll identify lang yung two general methods na ginagamit in analyzing our indeterminate beam. We have yung force method or yung flexibility method or yung displacement or stiffness method. So, very straightforward yung meaning niyan na in number one, force method, we are relying our analysis on the response of our beam based from the forces applied to it. And then sa displacement method, of course, kung ano yung magiging deflection o yung magiging um, elastic curve ng mismong beam natin, doon natin ibe-base yung formula natin of solution para doon sa indeterminate beams natin. Pero we will not be able to cover both of this one, especially yung number 2, no? We will just cover siguro yung number 1 by next week. What we will tackle today is just yung another method, hindi siya official method, pero we can use double integration method to calculate for the value of the reactions ng indeterminate structure natin. Kaya hindi ginagamit si double integration method kasi it will be very tedious comparing it with these two methods na nakalagay dito. Pero in using these two methods kasi, you need other knowledge or prior knowledge dun sa pag-analyze niya na hindi na siya scope nung course natin, sa course description natin. Kaya it is very difficult to um, to to share or to actually solve this method kapag wala tayo ng prior knowledge nung ibang analysis natin for deflection. Kasi in our case, in civil engineering, we have two courses ng analysis wherein yung statically determinate structures is yung first course and then yung second course is yung statically indeterminate. So, in your case, this particular division nung type of structure natin is combined in one subject lang. Kaya it would be very time constraint talaga. Kaya what I'm suggesting or what we will do today is to utilize what we have learned from the semifinals and apply it here so that we know kung ano yung nangyayari dun sa mismong method of solution natin. Okay? And then for next week, we will discuss yung force method. I will try my best to explain yung force method and to use yung force method to solve again the same examples and then let you decide what is more convenient to use. No? So, discretion na nila kung ano yung gusto nyong i-apply sa mga methods na i-discuss natin. Pero as I've said, for today, we will be using yung double integration method. So how can we utilize this method in solving for the reaction of indeterminate beam? So let's proceed with our example na. Okay? Ayan. So let's say we have a continuous beam. Hindi na siya simply supported beam, no? Kasi tatlo yung support natin. We have a hinge, a roller, and a roller. So when we try to identify the number of unknown reactions natin, we have a vertical and horizontal for the first one at A. Lagyan ko lang ng notation. This is A, this is B, and this is C. For the middle support, we have a vertical, and also for the last one, we have vertical. So as we can see here, we have 4 reactions, but ang equations of equilibrium natin is only 3. So ibig sabihin, excess tayo ng isa. So statically indeterminate tayo sa first degree. Okay? So let me revise lang this. This should be 200,000 megapascal. Okay? So, ang pinaparo sa atin is find the reaction of A, B, and C. So, how can we use this? So, to use this formula, we can actually um, prefer yung katulad ng method natin dati na magse-segment tayo kung saan may different forces tayo. So, dito, ano-ano ba yung mga forces na pwedeng mag-contribute dun sa performance ng mismong structure natin, no? So, makita natin dito, meron tayong 100 kilonewton na load dito. So, ano sa tingin niyo yung magiging elastic curve natin? Okay? So, yung elastic curve natin siguro, since nandito yung pababa niya, so dito sa position ng support natin should be 0 yung ano natin, no? Yung deflection natin doon. Okay? Based from our previous ano no, discussions, dito is 0 yung displacement niya. So kung 0 doon, definitely yung beam na yun magde-deflect diyan. Ano mangyayari sa remaining beam? So remaining beam natin magaganyan siya, no? Kasi ipo-pull niya pababa yung beam, yung segment na to. Okay? So yung magiging elastic curve natin is pa ganyan. Okay? So to solve for our reactions, we can use yung segment natin to know or to identify yung mga formulas na kailangan natin for compatibility condition. So, ilang segment tayo? So, yung first one will be before yung loading natin, or we can okay, so okay, so pwedeng halimbawa dito na para support by support tayo. Ito yung first segment natin. Okay? So yung first segment natin will be the effect of 100 kilonewton dun sa distance from 0 hanggang dito sa half natin or sa 7 meters natin. And the other segment from 7 meters hanggang 14 meters natin. Okay? So dapat ngayon by now alam natin na dapat ang reference axis lang o reference point natin for 0 meter lagi is yung left support natin, yung leftmost support. Okay? So, let's use that. So, ito yung first segment natin and then second segment natin. So, we need to get yung moment equations ng first and second segment so that we can arrive with relationship ng mismong mga forces natin. Okay? So, this will be RA, RB, and then RC. Si horizontal, I will not include na kasi wala naman tayong horizontal force. So, assume ko na lang na 0 yon. So, yung first equation natin na gamit is summation of forces. Y is equals to 0, taking upward as positive. So, ibig sabihin ng formula natin is RA plus RB plus RC is equals to 100 kilonewton. Ito yung first equation natin. Okay? Next, summation of moment at A. Okay? Is equals to 0. Taking clockwise as positive. So, taking clockwise as positive, so 100 kilonewton times 3.5 meters minus RB times 7.0 meters minus RC times 7.0 meters is equals to 0. So, yung ating next equation will be transfer lang natin sa kabila, no? So, we have 7RB plus 7RC is equals to negative 100 times 3.5, that is 350 kilonewton liter. So, ito yung second equation natin. Okay? So, as you can see dito, meron tayong 3 unknowns. Okay? Yan. Ito. 3 unknowns pero 2 equations lang. So, hindi enough yung equation natin to solve for the value of our reaction. So, kailangan natin ng um, equations natin from each segment natin. Okay? So, yung first segment natin, that's right. So, this is our first segment. So, ito yung kanyang cut ng section natin. And then, ito yung reaction natin na RA. Okay? Then, we have here yung ating 100 kilonewton. And then, kung X to, this will be X minus 3.5. Okay? So, kailangan natin dito at point O, makuha yung moment natin at that section. Tawagin kong moment in terms of X nung segment 1 natin. Okay? So, get natin yung moment, summation of moment of X. Summation of moment at point O is equals to 0, taking counterclockwise as positive. So, we have mx of 1 plus 100 kilonewton times x minus 3.5, okay, is equals to or minus RAX is equals to 0. So, yung first moment natin, first moment equation is equals to negative 100 kilonewton x minus 3.5 plus RAX. Okay? So, ito yung isang equation natin for the first segment. Then, next is, let me reduce na lang this one kasi this is okay. Lagay lang natin dito sa side. Okay? So, yung second segment natin, okay? So, ito yung cut natin. So, sa second segment, kung ito yung gagamitin natin, left side, madami pa tayong reaction, no? Pero we can use yung right side natin, which is also equal naman do sa magiging value ng force natin doon. So, using our right side, nung segment 2, okay? Ang forces na lang natin dito is RC. And then, ano yung distance natin? Kung si X is locate natin from dito sa point na to, ibig sabihin ito ay X and then ano tong value na to? So 14 minus X na siya dito. So ibig sabihin this is 14 minus X. Okay? So kailangan natin yung moment na to. Moment of X ni second segment. So summation of moment ni X. So at 0 is equals to taking clockwise as positive. So, yung clockwise natin will be mx2 minus rc 14 minus x is equals to 0 or m of x2 is equals to rc 14 minus x. Okay? So, ito yung equation natin. So, we have now two moment equations. Ang gagawin natin, kunin natin yung slope and deflection ng each segment natin. Okay? So, okay, paano natin gagawin ito para hindi tayo malito? So, yung una muna, gamitin natin yung sa first segment. Okay? So, yung E ay, lagyan ko ng subscript na 1 is equals to mx of 1. Okay? So, yung value natin is negative 100 kilonewton. X minus 3.5 plus RAX. Okay? Perform natin yung integration natin. We have EI, VI prime is equals to negative 100 kilonewton. X minus 3.5 squared over 2 plus RA x squared over 2 plus C1. I-simplify natin. We have negative 500 kilonewton multiplied by x minus 3.5 squared plus 0.5 ng RA x squared plus C1. Ito yung ating slope equation. And then integrate pa natin by another one, we will have our deflection equation. This is equals to negative 500 kilonewton times x minus 3.5 cube over 3 plus 0.5 RA x cube over 3 plus C1x plus C2. So, ito na yung magiging equation natin for our first segment, no? Okay? So, yan yung sa first segment natin. Now, we use yung second segment natin. So, let me copy lang this one. Then, kunin natin to. So, sa segment 2 natin, segment 2, so we have EIV2 double prime is equals to MX2 tapos RC14X. So, integrate. So, we have EIV2 prime and then we have RC. And then, bago nyo siya i-integrate, kailangan di ba sasatisfy natin yung dx dito na dapat negative dx yung derivative niya. So, kailangan mag-multiply tayo ng negative 1 over 1. No? So, dapat yung answer natin dito magiging negative 2. Then, 14 minus x squared over 2 plus C3. No? C3 na tayo ngayon kasi nagamit na natin yung 1 and 2. Simplify natin. We have negative 0.5 RC 14 minus x squared plus C3. And then, integrate natin para sa deflection equation natin. So, we have negative 0.5. Again, this is a negative quantity. So, kailangan mo-multiply ulit natin by negative 1. So, this will be a positive number na. Okay? 0.5 RC 14 minus x cube over 3 plus C3x plus C4. So, ito na yung magiging equation natin for segment 2 natin. So, anong gagawin natin doon sa equations na nakuha natin? These equations will now be used. Okay? So, yung segment 1 natin, saan siya applicable? Pwede lang siya from 0 less than x less than 7.0. Okay? So, ibig sabihin sa first segment lang siya. Ibig sabihin, dito lang siya sa zone na to. Pwede, no? Yung equation na yan. Okay? Si segment 2 naman will be from the 7 meter mark hanggang 14 meters natin. So, dito sa segment 2 is from 7 less than x less than 14. Okay? So, tingnan natin yung elastic curve natin. Ito yung elastic curve natin. Okay? So, dyan tayo magbe-base ng compatibility equation natin. Ano yung makukuha natin compatibility equation? So, ang unang makukuha natin is from dito sa point A natin, sa first reaction natin, alam natin na ang ating at x is equals to 0, ang ating displacement dun sa area, dun sa location na yon is equal to 0. Okay? Pero ano yung nakakasakop sa kanyang segment? Si segment 1, no? Kaya ang V1 natin dito is equals to 0. So kung V1 is equals to 0, balikan natin yung deflection equation natin dito. Pag nilagay natin na 0 to, this will be 0 and then lahat ng may x will be 0, 0. Ibig sabihin si C2 ay equals kay 0. So ito yung first condition natin. C2 is equals to 0. So ito ngayon yung magiging third equation natin for our formula. Yung C2 is equals to 0. Okay? Next, ano pang meron dun sa ano natin? Yung pag chinek natin tong location dito, our second location dito, ano yung meron dito? Meron tayong 0 din na um, na na deflection dito sa point B natin, no? So kung considering yung segment 1, okay? Kung considering sorry. this is x is equals to 7.0. And then, yung V1 natin doon is equals to 0. Ano mangyayari dito ngayon? Okay? Pag nilagyan natin to ng value, okay, uh, pwede natin lagay. So, pag nilagyan natin ng value yung sa ano natin, sa deflection, this will be 0 yung deflection. And then, we will have a value for C1. Kasi identified natin na C2, ma-identify natin ngayon yung value ni C1. Okay? So, using this formula. So, let us copy this one para makuha natin yung next equation natin. Okay. So, dito natin sa substitute yun. So, this will be 0 is equals to negative 500 kilonewton times 7.0 minus 3.5 cube over 3 plus 0.5 RA. Then, this is 7.0 cube over 3 plus C1 times 7.0. And then, yung C2 natin will be 0 na. Okay? Based from our third equation dito, no? Based dito. So, ayan ang makukuha nating value ngayon. So, we will determine this one, pero ang magiging equation natin is in terms ni RA. Okay? So, yung C1 natin dito is equals to, transpose natin yung 500 over 3, 3.5 cube minus yung 0.5 over 3 RA, 7 cube. And then, i-divide natin both side by 7.0. Okay? So, yung C1 natin, pag inano natin, sinimplify, 500 over 3, 3.5 cube over 7, that is 1020.83 minus 0.5 over 3 times 7 cube. Mas divide mo ng 7, we have 8.17 RA. So, this will be our fourth equation. Okay? Yung relationship ng C1 tsaka RA. Next. Ano pa yung condition na pwede natin malaman? Dito sa location natin sa gitna pa din, makikita natin na yung slope naman natin, since pwede siyang mag-rotate, yung slope ng first segment and yung slope ng second segment should be equal kasi same point siya, di ba? So, dapat equal siya. So, ngayon, kailangan pag-equate natin yung formula ng slope equation ng segment 1 and slope equation ng segment 2. Okay? So, for, lagyan natin to ng mark, no? So, yung una nating condition, second condition, and then third condition natin, yung slope ng first segment ay equal sa slope ng second segment. Okay? So, kunin natin yung equation ng slope natin. So, ito yon. Ayan. Then, equals daw siya sa slope natin dito sa second segment natin. So, ito yung slope natin dito. Ito. Okay? Ayan. Adjust lang natin. Yan. So, ayan yung magiging fifth equation natin. Okay? Ayan. And then, ano pa ang pwede natin gamitin? Let's go dun sa ating last support. So, last support, ang deflection dito will be 0. Okay? Pero ang segment lang na pwede natin magamit is si segment 2 lang. So, ibig sabihin, at x is equals to 14 or dun sa pinaka-length natin, magiging condition ng ating deflection at that point will be 0. So, lagay natin yon. Ito yung pang-apat na condition natin. At x is equals to 14.0, yung V2 natin will be equals to 0. So, ano yung makakalculate natin dito? Pag tinignan natin, dito, ito yung ating equation. Pag naging 0 to, okay, substitute natin yung x na 14, this will be 0. This will be C3, 14, okay, times 14, then C4. So, magkakameron tayo ng relationship ni C3 tsaka ni C4. Okay? So, kunin lang natin to. Ayan. So, this will be 0 is equals to, this will be 0 na yung first term plus C3 times 14 plus C4. So, meron tayong relationship ngayon na 0 is equals, or gawin natin 14 C3 plus C4 ay equals kay 0. So, ito yung magiging sixth equation natin. So, ilan ang unknowns natin ngayon? We have 6 equations now, and how many are our unknowns? Meron tayong unknown na C4, C3, C2, C1, and then yung unknown natin na A, B, and C. So may isa pa tayong equation na nawawala, no? So ano pang relationship yung pwede nating kunin? Um, Saan pa ba sila pwede? So we have 1, 2, 3, 4, 5, 6. Meron tayong 4, C2. Hmm. Okay, so let's check. Ganito, we have two equations dito. 1, 2, 3, 4, and 5, and 6. A, B, C, 1, 2, 3, 4. Kailangan natin ng 7 equations. Kulang tayo ng isa. Where do you think yung pwedeng equation natin doon? So, yung sa second one, sa second support, um, meron na tayo nung para sa slope. Okay. Kasi yung slope ng first support and last support will not be zero kasi pwede siyang mag-rotate, no? So, hindi natin siyang pwede i-equate sa zero. So, let's check kung meron tayong relationship na makuha dun sa mga meron tayong forces ngayon or equations ngayon. Okay? So, i-rewrite ko lahat ng equations natin. Let me use this. Ayan. Yung first one natin. Second one natin. Okay. Kunin natin si third one. Si fourth one, kunin natin. Fifth one natin is this one. Then yung sixth natin is ito. Okay, so ito yung mga unknown equations natin. Let's see kung pwede natin solve na siya or meron tayong pwedeng i-solve. Okay? So, hmm, hmm. So ilan ang unknowns natin? 1, 1, 2, 3, 4, 5, 7 talaga. May nawawalang isa. Okay? For a while nga lang, try kong isipin kung nasaan yung nawawalang isa. Okay, so yung other equation na nawawala natin is from the second segment na 0 yung kanyang deflection dito. Okay? So hindi natin na-consider yun. Okay? So um, let us add dito and then transfer ko lang tong side na to so that we have two equations and two unknowns. We have enough equations para dun sa unknown natin. Okay? Ayan. So kunin natin yung isa. We have our fifth one. So at x equals to 0, at x equals to 7.0, yung V2 natin is equals to 0. Kasi itong nakalagay dito is V1 pa lang, no? So yung sa V2 naman. So kunin natin ulit to. And from here, pag nag-0 si V2, so 0 to, so ito will have a 7 value. Okay? May makuha tayong relationship ng C3 and C4. Okay? So this is 0 is equals to 0.5 RC. This will be 14 minus 7 cube over 3 plus C3 times 7 plus C4. Okay, so we have 0.5 times 7 cube over 3. That is 343 over 6 RC plus 7C3 plus C4 is equals to 0. So ito yung ating seventh equation. Ayan. Okay, so dito natin lalagay seventh equation natin. Right, so paano natin ngayon gagamitin tong mga unknowns na to? Okay, so okay. So makikita nyo dito, ito, may 7 equations tayo, 7 unknowns. Kung marunong kayong mag-matrix, pwede yung matrix yung gamitin niyo. Pero hindi natin gagamitin si matrix. Ang gamitin natin is substitution tayo. Okay? So, ang pwede natin kunin as our formula is yung una muna, yung 6 at 7 natin. Since may C3 and C4 tayo, okay? So, pwedeng yung gamitin natin is yung 6 and 7 natin. Okay? So, ang gagawin natin, yung 14C3 plus C4 is equals to 0. Tapos 343 over 6. 343 over 6 RC plus 7C3 plus C4 is equals to 0. Kailangan ma-eliminate natin yung isang unknown sa kanya para magamit natin yung magagawa nating bago. So gawin natin pag minusin natin siya, no? So pag pinag-minus, magche-change yung sign nito. Okay? So magiging negative 343 over 6 RC. Then this will be plus 7C3. And then yung C4 natin will be canceled out. So ito yung magiging bagong equation natin. Tatawagin kong equation number 8. Okay? This is in terms ni RC tsaka C3. Anong formula yung may RC and C3? So itong formulang to, no? Yung relationship na to. So pwede nating i-relate yun dito. Okay? And dito magagamit naman natin mamaya si C1, no? Para dito sa RA natin. Okay? So gamitin natin yon. So using equation gawin ko sa equation 4, equation 5, and equation 8. Dito. Ibig sabihin, si C1 na value, sa-substitute natin dito sa C1 dito. And then si C3 na value, substitute natin dito para makuha natin yung RC. Okay? So ito pag in terms ni C3, that will be 343 over 6 RC tapos divided by 7. Okay? Or gawin natin over 42 na lang. Or C3, 343 over 42 RC. Okay? So this will be negative 50 x minus 3.5 squared plus 0.5 RA x squared. Actually, yung fifth equation natin, pwede pala natin i-simplify pa, no? Kasi yung x value nito ay equals sa 7. So, pwede natin substitute yung value niya dito. Okay? So, let's do that. Ito kung nalagay sa taas. So, substitute natin yung 7. We have negative 500. Negative 500 times 7 minus 3.5 squared plus 0.5 RA 7 squared plus C1 is equals to negative 0.5 RC. 14 minus 7 squared plus C3. So, pag sinimplify, 3.5 squared. So, this will be negative 6125 plus 24.5 RA plus C1 is equals to negative 24.5 RC plus C3. So, ito yung bagong equation number 5 natin. Ito yung kakopy ko dun sa last slide natin. Okay? So, again, medyo tedious talaga to, no? Kaya, please bear with me. Okay? Ito yun, equation 5 natin. Yan. So, dyan natin sa-substitute ngayon yung values natin na 4, 5, and 8. Okay, so we have negative 6125 plus 24.5 RA plus yung C1 natin from equation 4. So, 0.83 minus 8.17 ng RA is equals to negative 24.5 ng RC plus yung value ng C3 natin from equation 8 over 42 RC. Okay? So, combine natin yung like terms. So, negative 6125 plus 1020.83. That is negative 5104.17 RA. Hindi po pala RA ito. Then, 24.5 minus 8.17. That is plus 16.33 RA. Nangyari? RA is equals to, yung RC natin, combine lang natin, negative 24.5 rubs 343 over 42. That is negative 49 over 3 RC. Okay? Ayusin lang natin to. 16.33 RA plus 49 over 3 RC is equals to 5104.17. So this is our ninth equation. Okay? Makikita nyo, may relationship na tayo ng RA and RC. And saan natin siya pwede i-substitute? Pwede natin siyang gawin dito sa formula dito. Sa equation 1 natin. Kasi meron tayong RA and RC doon. And then yung dito, pwede natin gawin si RB in terms ni RC. So ang mangyayari, magiging in terms ni RC na lang lahat yung ating equation. Okay? So medyo overtime tayong konti, no? Para matapos lang natin tong equations na to. So let's do that. So, gagamitin natin sa equation 1 and equation 2. Let's copy this one. Ito. Ayan. And equation 3, equation 9, sorry. Gamitin natin dito. Ayan. So, using 1, 2 and 4. Okay? Um, Gagawin natin in terms ni C lahat. Okay? So, ibig sabihin sa equation 9, gagawin natin RA is equals to 5104.17 minus 49 over 3 RC. Tapos multiply natin both sides by 1 over 16.33. Okay? So that will be 5104.17 over 16.33. This is 312.564 minus 49 over 3 divided by 16.33. That is RC na lang. Okay? Ito yung RA natin. Dito, yung RB natin, gawin natin in terms ni RC. So this will be 350, negative 350 plus 7 RC multiplied natin by 1 over 7 or equals sa 350 divide 7, that is negative 50 plus RC. So pag sinubstitute natin ngayon sa first equation, we have RA natin is, ito yung first equation natin, 3A plus 3B plus RC, sorry, 3 na pati ang nasasabi ko, 100 kilonewton. Substitute natin yung RA, ito. So 312.564 minus RC plus yung RB natin, ito, negative 50 plus RC plus RC is equals to 100. So combine natin yung like terms. So dito magka-cancel out yung RC natin. May matitirang isang RC. So combine natin yung 312.564 minus 50. That is 262.546. Okay? Plus RC is equals to 100. O yung RC natin ay equal sa 100 minus 262.546. So equal siya sa negative 162.546 kilonewton. Ayan. So meron na tayong first equation para dun sa first answer dun sa problem natin. Na ang value daw ng RC ay equal sa, ayan, which is negative. Ibig sabihin, yung assumption natin na upward siya kanina should be downward. Kasi nga, yung ating elastic curve dito is paganyan. So kailangan niyang i-bring down yung RC, yung ating value para bumalik siya sa 0. Okay? Then yung value na nakuha natin for RC, sa-substitute natin dito. So yung RB natin will be negative 50 plus negative 162.546. So that will be 162.546. So this is negative 212.546 kilonewton. Okay? So mali ulit ang sign. So dito 312.5464 minus 162.546. Okay? So 312.564 minus 162.546. This will be 475.11 kilonewton. Okay? So ito yung ating RA, ito yung ating RB. So this will be our reaction for this problem. Okay? Ayun. So super haba lang ng equation pero lumabas naman yung reactions natin. Okay? So ibig sabihin dapat ang ating reaction should be upward to, downward to, and then downward to. Okay? Question dito? Okay, so please try to reanalyze ulit yung mga sinolve. I know medyo mahirap sundan sa ngayon, pero please try to step by step natin balikan yung lahat ng sinolve natin dito. Okay? So for the other example, ito na lang yung di-discuss ko sa other section para ito naman yung i-share ko na lang yung solution sa inyo. Okay? Pero if you don't have any other concern, this ends our lecture for today. Okay?